Air is our topic that we are going to cover today. Here we will see the atmosphere and the composition and the structure of atmosphere. So we will cover the troposphere, stratosphere, mesosphere, thermosphere and exosphere. After that we will see weather and climate, what is weather and climate, and what is the role of temperature, air pressure, and then types of wind. Then we will also see a natural fury, that is cyclone. We'll try to understand what is cyclone, then moisture in the air, and the types of rainfall, that is the convectional, relief and cyclonic rainfall. So let us start the topic. So atmosphere, our earth is surrounded by a huge blanket of air called atmosphere. So this is atmosphere, where our earth is surrounded by a huge blanket, that is atmosphere. All living beings on this earth depend on the atmosphere for their survival. So whatever the living things are there in the earth, so they all are depend on the atmosphere for their survival. Now how we will see this one. It provides us the air we breathe and protect us from the harmful effects of the sun rays. So the air that we are breathing just came from the atmosphere. Not only this, it also protect us from the harmful effect of the sun rays. Without this blanket of protection, we would be baked alive by the heat of the sun. So without this protection, what happened? We will be baked like a bakery biscuit by the heat of the sun and during the day, and get frozen during the night. So if this atmosphere will not be there, then we are going to be die, because in the daytime we will be baked, and at the night if we are survive also, then we are get frozen. So it is this mass of air that has made the temperature on the earth livable. So due to this mass of air, what happened? The temperature on the earth has become suitable for living beings to live. So this is the introduction of atmosphere. Let us see the composition of atmosphere. What is there? Atmosphere composed of what are the gases are there, right? So that atmosphere is a blanket of air surrounding the earth. It is composed of nitrogen, that is 78% present there, see here. It helps in plant growth. Then oxygen is there, that is the percentage is 21%, essential for respiration and combustion. Other gases are there, that is 1%, include carbon dioxide, argon and ozone. And after that, water vapor and dust particles play a role in weather changes. So these are the gases that we have seen: nitrogen, oxygen, other gases, water vapor and dust particles. Now carbon dioxide is crucial for photosynthesis but contribute to global warming. So here we have seen carbon dioxide is also there, that is among the other gases that is present in the atmosphere. It is crucial for photosynthesis but contributes to global warming also. The two gases that make up the bulk of atmosphere are nitrogen and oxygen, where the percentage of nitrogen is 78 and the oxygen is 21%, and the remaining are the other gases. Together they make up 99% of the earth atmosphere, with other gases like carbon dioxide, argon and water vapor present in smaller amount. Okay, so the two bulk gases is the nitrogen and the oxygen, and together they combine and make 99% of the gas in the atmosphere. Carbon dioxide contribute to global warming through the greenhouse effect. Sunlight reaches Earth, the Earth releases this heat as infrared radiation and back into the atmosphere. Carbon dioxide absorbs and traps some of this heat, preventing it from escaping into the space. And as more carbon dioxide accumulates due to human activities like the burning fossil fuels, deforestation, industrial processes, more heat is trapped, leading to gradual increase in earth temperature, that is global warming. So what happened? Carbon dioxide releases this sunlight reaches the earth, and the earth releases this heat as an infrared radiation, that is the heat energy. And this carbon dioxide absorbs and traps some of this heat, preventing it from escaping from the space. So as more carbon dioxide begin to accumulate, what happened? The heat begin to trap, leading to gradual increase in the earth temperature. Due to global warming, what happened? Increased heat leads to climate change. More heat waves, storms and unpredictable rainfall patterns we have seen. Not only this, carbon dioxide dissolves in seawater, harming the marine life, melting glaciers and rising sea level. So these are the effects of global warming. Since carbon dioxide remains in the atmosphere for a long time, controlling its emission is crucial to slowing down global warming. So we must control the emission of carbon dioxide so that it may slow down the global warming. So this is important, as in the examination also they may ask you the composition of the atmosphere, and secondly they will ask you what is global warming and how it may affect our earth. Okay, so here this thing has been covered. Now let us see the structure of the atmosphere. What is the structure of the atmosphere? So our atmosphere is divided into 5 layers starting from the earth's surface. These are the troposphere, stratosphere, mesosphere, thermosphere and exosphere. See here. This is the layers of atmosphere: troposphere, stratosphere, meso, thermo and exosphere. This is the height in kilometer. Okay. Now the first one is the troposphere. So its average height is 13 kilometer. So this is the troposphere. Okay. So its average height is 13 kilometer. The air we breathe exists here, and almost all the weather phenomena like the rainfall, fog and hailstorm occur in this layer. So in this layer all the weather phenomena happen, and the air we breathe also exists here. Now the second layer of atmosphere is the stratosphere. See, this is the stratosphere. Above the troposphere lies the stratosphere. It extends up to a height of 50 kilometer. This layer is almost free from clouds and associated weather phenomena, making condition most ideal for flying aeroplanes. Okay. Stratosphere contains a layer of ozone gas also. So here we will find ozone gas also. After that mesosphere is there, that is the upper level. So here this is the third layer of atmosphere. It lies above the stratosphere. It extends up to the height of 80 kilometer. So here 80 kilometer. And meteorites burn in this layer on entering from the space. So whenever the meteors burn here in this layer, they just enter from the space. After that thermosphere is there. See, thermosphere. In thermosphere, this is thermosphere, temperature rises very rapidly with increasing height. Ionosphere is a part of this layer. It extends between 80 to 400 kilometer, and this layer help in radio transmission. Okay, so the ionosphere help in the transmission of radio. In fact, radio waves transmitted from the earth are reflected back to the earth by this layer. So here what happened, the radio waves are transmitted from the earth and reflected back to the earth by this layer. Then we will find at the upper and the topmost layer is the exosphere. The uppermost layer of the atmosphere is known as exosphere. This layer has very thin air. Light gases like helium and hydrogen float into the space from here. So here very thin air is there, and light gases like helium and hydrogen float into the space from here. So this is the layers of atmosphere where we have seen the troposphere, stratosphere, mesosphere, thermosphere and exosphere. Now let us see what is weather and climate. Weather refer to short-term atmospheric conditions like the temperature, humidity, rainfall and wind, whereas climate is the average weather pattern over a longer period. So whenever we are talking about the climate, it is the average weather pattern over a long period, and weather is a short-term atmospheric conditions like the temperature, humidity, rainfall and wind. So let us see quickly what is temperature. The degree of hotness and coldness of the air is known as temperature. So the degree of hotness and the coldness of the air is known as the temperature. The temperature of the atmosphere changes between the day and night. From season to season, summers are hotter and then winters are cold. So the temperature of the atmosphere changes between day and night. So we will find a different temperature in the day, and at night also it is different. Not only this, from season to season also the temperature used to be different, like the summers are hotter and winters are cold. Insolation influences the distribution of temperature. It is incoming solar energy intercepted by the earth. However, insolation also influences the distribution of the temperature, and insolation is the incoming solar energy intercepted by the earth. The amount of insolation decreases from the equator towards the pole. Therefore, the temperature decreases in the same manner. So, due to insolation, what happened? The temperature decreases from equator towards the pole, and as a result, we see there is a decrease in temperature in the same manner in different areas. Now, what is air pressure? Air pressure is defined as the pressure exerted by the weight of air on the Earth's surface. As we go up the layer of atmosphere, the pressure falls rapidly. So as we are going up, the pressure is very low, it will fall. The air pressure is highest at the sea level and decreases with the height. So if higher altitude is there, then the low pressure will be there. High pressure is associated with clear and sunny skies, and low pressure is associated with cloudy skies and wet weather. The air always moves from high pressure areas to the low pressure areas. So in the fill in the blanks also, or in the MCQ question also, they may ask you air pressure moves from high pressure areas to the low pressure areas, right? So you can write this one also, and if it is there in the MCQ question also, then you can just tick from high pressure areas to the low pressure areas. Now this is the air pressure. Let us see wind. What is wind here? The movement of air from high pressure area to low pressure areas is called wind. So the movement of air from the high pressure area to the low pressure area is called the wind. Wind are moving air due to the pressure differences. It can be broadly divided into three types, that is the permanent wind, seasonal wind and the local wind. Okay, so this is the equator. Here we will see a low pressure, then Tropic of Cancer is there and Tropic of Capricorn. High pressure area is here, right? Then subpolar low pressure area and subtropical is the high pressure area. Now what is a permanent wind? The trade wind, westerlies and the easterlies are the permanent wind. These blow constantly throughout the year in a particular direction. So permanent wind blow constantly throughout the year in a particular direction, and these are the trade winds. Okay. Now seasonal winds are also there, as the name indicate. These winds change their direction in the different seasons. Example, monsoon in India. So this wind changes their direction in different season. Then local winds are there. These blow only during a particular period of the day or year in a small area. For example, land and the sea bridge. So this is the wind. After that we will see cyclone, a natural fury. What is cyclone? A cyclone is a large-scale system of wind that rotates around a low-pressure center. It is associated with strong wind, heavy rainfall and storm surges. So whenever the strong winds are there and heavy rainfall is there, so it can just be associated with cyclone. Tropical cyclone, these are the types of cyclones. So from over warm ocean waters, it just start. Example, the hurricanes and the typhoons. And temperate cyclones are formed in mid-latitude region due to air mass interaction. So tropical cyclones are formed over warm ocean waters, and temperate cyclones are formed in mid-latitude region. Now cyclone is formed when warm moist air rises from the ocean. So the question may arise, how cyclone is formed? So it is formed when warm moist air rises from the ocean. This creates a low pressure area surrounding air rushing in and forming strong winds. The Coriolis effect causes the wind to rotate, that is in the counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. And in this way the cyclone is formed. Now again, cyclone is categorized based on its speed. So if it is in less than 39 km per hour, then that is known as depression. Cyclonic storm, if it is the speed of the wind is between 39 to 89 km per hour, then it is known as cyclonic storm. And if the speed of the wind is 89 to 118 km per hour, then it is known as severe cyclonic storm. And if it is greater than 221 km per hour, then that is super cyclone. So cyclone can destroy buildings and uproot trees. It leads to flood and landslide also. It also rise seawater, floods and the coastal area. So it is a natural fury. Now moisture in the air, let us see what is moisture in the air. Humidity, the amount of water vapor in the air at any time is known as humidity. And condensation, water vapor turns into droplets like the clouds, dew and the fog is condensation. What is precipitation? Any form of water, that is the rain, snow or hail falling from the atmosphere is precipitation. So these are the moisture in the air. Now let us see the types of rainfall. Here we will see three types of rainfall: convectional rainfall, relief rainfall and cyclonic rainfall. So intense heating of the land causes warm air to rise, and it is common in equatorial region. Due to this, what happened? Convectional rainfall occur. Then relief or the orographic rainfall. Whenever the moist air, see this is the moist air, is forced to rise over mountain, Then we will see orographic or relief rainfall, and it is common in Western Ghat, that is in India. And cyclonic rainfall, that is interaction of warm and cold air masses. So here warm and the cold air, whenever they interact, cyclonic rainfall is there, and it is common in mid-latitude region. So the atmosphere is essential for life on earth. It provides oxygen for respiration, protects us from harmful rays, and influences weather and climate. Understanding air movement, pressure and moisture help us to predict weather patterns and climatic changes. So this is the topic air, where the atmosphere play a very essential role. So here we have seen the composition of atmosphere, where we have gone through the gases, nitrogen, oxygen and the other gases. Then the structure of atmosphere is there, the 5 layer of atmosphere. After that we have seen what is weather and climate, and what is temperature, air pressure and the types of wind. Then cyclone is also there. In moisture we have seen the moisture in the air, that is the humidity, precipitation and condensation, and types of rainfall, that is the convectional, relief and the cyclonic rainfall. So this much for today.